My name is Mason Hochstetler. I am a student in Dr. Warner's lab studying opioid use disorder with a focus on fentanyl. As you're probably well aware, within the United States as well as the world, there is an opioid crisis. As you can see on this map here, there was a significant increase between January 2020 to January 2021 across the board in 37 states in the United States of non-fatal opioid overdoses. Now, the most common way to study substance use disorder is to implant a catheter within the heart of an animal with a tether attached to that catheter, which is then attached to a pump. Now, our lab is focused on using cutting-edge technology such as miniscopes that have cables attached to them that could potentially tangle with this tether and cause issues. So how do we circumvent this issue? Well, to do so, we have started using vape technology, using these vape tanks that you can purchase commercially at any smoke shop within the world, which adds some validity to our data. These vape tanks are used in tandem with these vacuum sealed containers, where the tank is placed on an atomizer that heats up the tank when the animal has nose poked in a certain amount of times to receive the reward, which then delivers a vapor to the chamber. Now here you can see there's a schematic showing all the individual parts, and our first set of data that we did a 1-hour self-administration study of fentanyl versus vehicle. Within the first 3 days, the animals received a 3-second puff of their respective treatment, and on the 4th day, we changed this puff to 1.5 seconds to allow the animals to have to work harder to receive the same high they had before. And as you can see, there is a significant increase in drug-taking behaviors in the fentanyl group versus the vehicle group. Next, we did a seeking test where the animals were placed back in the same chambers. No reward was available, however, but they were still allowed to nose poke. And as you can see, the fentanyl group significantly had an increase versus the vehicle in drug-seeking behaviors. The next step for this was that we did a 6-hour self-administration study, very similar to the first one, except all the animals received fentanyl. And for the first 3 days, they were in the chamber for 1 hour with a 3-second puff, and on the 4th day we increased the time to 6 hours with a 1.5 second puff. And as you can see, the animals had a higher increase in drug-taking behaviors as compared to the 1-hour group of animals. Now, I mentioned before that we wanted to use cutting-edge technology such as miniscopes, and in this image here you can see that there is a schematic showing the individual parts of the miniscope, as well as the camera itself on the tip of a finger. It weighs about 2 grams, which can be implanted within the brain region of choice within the mouse, and he wears it on his head. We also inject a virus into this region to cause fluorescence within the cells of interest, which you can see here in this histology. The grin lens is implanted to the PRL just above where the virus has been expressed, which that virus expression looks like this image here, where individual neurons can be identified using data processing software and allow us to track them longitudinally. So what else do we want to use? We also want to use deep behavior analysis through machine learning. So using these white matter cameras pictured here, we take a top-down video of the mouse in the chamber, which we can then extract frames from and label individual parts such as the nose, ears, head, arms, and legs, which the machine can then look at these images over time to actually learn their behavior and predict and track their pose, which can identify behavioral microstates such as these right here, such as a lever press, retrieval of food pellet, and then consumption of food pellet. Now, what do we want to do all together? We want to record calcium transients from neurons in the prelimbic cortex and the nucleus accumbens, and also use the machine learning I mentioned previously to identify these behavioral microstates in fentanyl mice. Now, a new direction that we'd also like to go is we would like to examine how stress during drug abstinence actually affects relapse behaviors. Does this increase it, or is there no change at all? But our overall full goal is to examine the neuronal symbols that encode drug-related behaviors to gain a deeper insight into the neurobiology that underlies OUD. Thank you very much.